Welcome. In this video, I'm going to show you how to find the volume of a solid of revolution, that is a solid generated by rotating a given region, in this case f of x equals the square root of 3 minus x, bounded in the first quadrant, about a particular axis, and in this case we're using the x-axis. Now for problems like these, it's always a great start to begin with a picture. So let's start with a picture. So here's a sketch of our region, and in fact this is the region we're looking at. So this is the region that we'll be rotating, and we'll be rotating this region about the x-axis. So let's draw the resulting solid. So here is the resulting solid. When we rotate it again about the x-axis, it looks kind of like, I don't know, a parabolic bowl. So here would be the top of the bowl, and you'd be able to like pour food or cereal or water in here, and it'd be sideways so it would spill out. Anyways, that's what our solid looks like. So the first thing we need to do is we need to determine what a cross section looks like and find the area of that. And we want the area because if you recall, the volume of these solids is simply just the integral of the area. And it can be written in two ways depending on whether you're integrating with respect to y or with respect to x. So after you have your pictures, you always want to figure out what the area is. And actually it helps to have a third picture. So let's go ahead and sketch a cross section. So imagine this is kind of like a parabolic wedge shape of cheese on your cutting board, and you're getting your knife and you're cutting a wedge of that cheese out. That's my wedge. So my slice would be right here, and I'm going to make it a thick slice. There we go. So I can have a nice thick slice of cheese to snack on there. So that's my slice coming out of my wedge. And what is the width of this slice? Well, the width lies parallel to the x-axis. So the width is actually the change in x. So we're going to be integrating with respect to x. And now let's go ahead and sketch the cross section. There is the slice. So now instead of staring at my wedge of cheese from the side here like I was doing before, now I'm standing in front of my wedge of cheese and staring at it in this direction. So here is the center, and this center on this 2D sketch matches up or corresponds to the center here. And now let's look at the radius. The radius is here on my circle. And I know that the area of my circle, A, equals pi times the radius squared. Now I need to use this sketch to figure out what my radius is. And sketching in blue from my center out, we can see that the radius is actually determined by this curve. So if I were to take a slice here, the radius is taller. If I were to take a slice starting here, the radius is smaller. So my radius is actually, in this case, just equal to y. So in this case, radius is equal to y, which is equal to the square root of 3 minus x. So the area of this cross-section slice in the shape of a circle is given by pi times the square root of 3 minus x, and this whole quantity squared. And that's just pi times 3 minus x. So now that I have this, I can find the volume, and my volume is that area with respect to x, and we're integrating. If you notice, x runs from 0 all the way to what is this value? Take a moment and see if you can figure that out. If you said 3, you're correct. So from x equals 0 to 3. But instead of writing a of x here, I can replace that with this formula. So let me go ahead and do that now. So all I'm doing is, you can see I made a copy of this, and I'm going to move it here because that's my area formula. So let's go ahead and integrate. Integrating, we get pi times 3x minus x squared over 2, and we're evaluating from 0 to 3. So this becomes pi times 3 minus 9 over 2, and this will simplify to 9 pi over 2. So the volume of this solid here is 9 pi over 2. And if we quickly get our calculators out, this volume is approximately 14.14 units cubed. I hope this video was helpful.